Hello, everyone. I hope that you had a good day so far. It's Friday. Let's get our calculus dose into our blood before we go hibernating the whole weekend. So we have started section 5.2 where we now know what is definite integral. And we learned that, well, the definition is so painful, sometimes complicated, and sometimes impossible to do that relying only on doing Riemann sum, limit of Riemann sum could be not a good idea. So we have to start knowing these definite integrals a bit better by studying their properties and hopefully using the properties to evaluate that. So the most important one, I will keep it for the end. That is called fundamental theorem of calculus. But today we will study some of these properties. First one, we actually covered yesterday, the first one, which was, area and definite integral are related. We know that if we are integrating a function, which doesn't need to be a positive function, but here I'll consider something which is somewhere positive, somewhere negative. So in that case, if we know how to find the area of each region, then I can evaluate the integral. So this will go with area of R1 plus area of R3, the parts that are above x-axis, minus the area of the part that is below x-axis. So this we did use. In some cases, we evaluated some integrals using this property, but very simple, very limited number of those ones. The other property, this is called linearity of definite integral. What does that mean? Well, we have studied this in different cases. So if you have two functions added, and you want to find definite integral of these two functions added as the sum of two functions, this you can do integrate each one. And then add the value of those integrals. So integral of sum is sum of integrals. Well, if it is subtraction, also you can do that. These are easy, by the way. Just using Riemann sum, showing these properties is just, use the Riemann sigma properties, sigma notation properties, and limit properties, and it will give you right away these properties. And the other one I want to fit in somewhere here so that I can use the other board for my next work. So integral of dx. I don't know where to write that. It's this property and that property together, this is what makes integrals called linear functionals or you don't need to know what's functional. But those are the important ones. And I want to do some examples for these properties before we move on and do more other properties here. Any questions, any comments before I go ahead and do some of these? Okay. For example, I can now say, okay, well, I know how to do this one because I can sketch the graph of each piece or the whole 2x plus 1, and then area of the regions defined by this graph is not difficult to find. But something like this one would definitely be an interesting case. Okay? Let me do the first one and show how you can use this, at least simplify what we know. Later on, you will see that, oh, these properties are very important, even with the big gun fundamental theorem of calculus in hand. So here, I can say that, OK, I have two functions, 2x and 1 added. So I can separate each one and try to evaluate it. Yes, please?
The sign of 1.
Oh, it's from -1. Ooh. Ooh. Was it from -1 really from my notes? Yeah, it says it's -1. Then I can do take out the constant. Now, I can look at this and say that, oh, this is the function x. So function x, when you look at it, I wish it was from 0. From -1 to 3, it is giving us two regions, well, limited to this graph and the x-axis. One is below x-axis, one is above x-axis. So I can say, let's then take the -1 and find the area of the -1. But since it is under the x-axis, I will subtract that. Plus area of the positive side, which has 3 here, 3 there. But all these coming from this integral, from -1 to 3, they all is multiplied by 2.
Just the constant.
Okay? That's the first integral. The second one, this is area of, this is 1, this goes all the way to 3, this goes to -1. And the region this is defined is a simple rectangle. Yeah? I will write this one over there. 2 times area of this 1 times 1 divided by 2, and there's a negative sign multiplied to that, plus area of this one, 3 times 3, 9 over 2, plus area of this rectangle. The height is 1, the width is 4 times 1. There we go. Now I have 8. 2 times 8 over 2 plus 4, which gives me 12. Yeah. My focus here is to use the additive properties or linearity of integral, definite integral, to evaluate that definite integral. Yes, please.
The area of the rectangle.
The area of rectangle, look, the last piece here is +1. Yes? I separated, I have integral of 1. Integral of 1 means what? Means the area under the graph of function f of x equal to 1 from -1 to 3. So that's the constant 1. This is the interval. That's how you form that rectangle. Yeah? Any other questions? How about I give you 90 seconds to break down that into pieces, use the linearity, evaluate each piece, and then add and give me the final answer. 90 seconds, go ahead, please. You have 30 seconds left. I can use both properties in one step, and I can write this integral as sum of multiples of two simpler integrals. And this guy here is, okay, I have the function f of x equal to x, and I go from 1, 0, 1, 2, 3, 4. So I need to find area of that. Plus 3 times this guy there, y equals to root of 16 minus x squared. Y squared plus x squared is equal to 16. That is the curve defined by this equation is a circle centered at 0 at origin. The radius is 4. But we are only taking the positive side. It means that the semicircle all the way here, radius 4. And I'm only using the ones that goes from 0 to 4. So that's the part I'm using, and that's the region whose area will be counted in here. So this is 2, 4 times 4 divided by 2 plus 3 times pi r squared divided by 4. That is 16 plus 12 pi. Yes, please.
For like this circle, why did you only like count the area above the x-axis?
Because, see, the graph that I'm using, the function that I'm using is square root of something. Square root is always positive. In other words, the values that I'm using, values of y that I will use in this equation, are only positive y values. That's why I can only see above x-axis, which gives you the semicircle. Yes? Yes, please. Pardon? Oh, how do I get the radius? Here, if you have x squared plus y squared equals the number, that number is radius squared. In other words, the square root of that number is your radius. Yeah? Any other questions? Any other comments? Let's do an iClicker question, which is related to these properties. Combinations of both of these properties that you see on the board. Can anyone please confirm that you can see the question? Yeah, do you see it? Okay, perfect. Got 1 more minute left there. Okay. So the first thing here to note is that I can use the linearity property, and I write this as, okay, this guy minus 2 integral of dx plus integral of x dx, 0 to 1, plus integral of 1 dx. 4 integrals, yes? The first two, they're given here. That's 2, that's 3. So I have 2 times 4, 8, minus 2 times 3, 6, plus. Now, this is x. I have a way to calculate that. Hopefully, soon we will get rid of these methods here. So I have to take the area of that triangle from there, plus area of constant function 1 from 0 to 1. So in this case, we get a square or rectangle, whatever you want, yes? So that gives me 8 minus 6, 2, plus 1 times 1 divided by 2, half, plus 1 times 1 is 1. That is 7 over 2, yes? 1 over 2 plus 6 over 2. Any questions, any comments? Putting your answers, I'm closing the pool. Okay. So now that we have everything in place for these properties, I can move and do a new property. What is the next property? So we have worked in this property. We have related the definite integral to the old friend area. In the second one, we have worked on how integral works nicely with the integrand. Addition goes to addition, subtraction goes to subtraction. Now, the other thing that we have to consider are the properties of integral when it comes to the bounds or limits of integral. Some of these properties are just straightforward result of the definition of definite integral. Some of them are kind of notation, new thing introduced, or properties. If you leave what we had so far a bit not rigid, you will get these ones. Well, mathematically, there are ways to get these things sorted out in a nice way. But what we need at the end is to remember these properties. Integral of function from a to a. Well, just simple way of seeing this is that you have a function from a to a. You want to find the area of that line. A line doesn't have any area, so that must be 0. Second one. So far, I have always said that the lower bound or an upper one, there should be lower bound or lower left end point of an interval and right end point of an interval. But from this point on, I want to be able to play with that idea and allow my lower bound to be bigger than my upper bound. In that case, again, I said earlier, this one can take as the definition for that case, or just take things a little bit not very rigid, then you will get that. So flipping the two limits of two bounds of your integral, it will get a negative sign multiplied to your integral. The third property, which is very important property, is that your integral, you can break it up into smaller pieces of integrals, which each one integrates your function on a smaller interval. So if you are integrating from a to b, f of x dx, okay, if f is positive, you're trying to find the area of the region under that, yes? I can break it into two pieces. I can find the region, the area of that region, and then add that to the area of that region. So in other words, my function integral from a to b could be written this way. It can be broken down into integrals on smaller subintervals. The key point here is that you have to see that integral goes from a to c. The next one starts from c and goes to b. Yes? That is the important part of that. Let's do some examples for that, but meanwhile, is there any questions, any comments related to these? questions here. Okay. Example. Write the given terms as one definite integral. I have integral from 1 to 2 of gx dx minus from 3 to 2 gx dx. Integral from 0 to 1 of gx dx plus from 0 to 4 of gx dx. The third one, 1 to 2 of f of x dx plus 2 to 3 of f of x dx minus 1 to 4 of f of x dx. Okay? So if you know those three properties that I have written down on the board, you can combine those integrals and write them as one integral. Go ahead, please, and try to do that one, those ones, and I'll give you 30 seconds to complete that. Oh, not 30 seconds, 90 seconds. Where are you leaving? Okay. See you on Monday. Okay, the first one, okay, this is very important to see here that I can flip this one and get this one positive. So 1 to gx dx plus integral of 2, 3 gx dx. Now, I start from A, go to C, then next one starts from C, go to B. So these I can put together and write one integral. Okay? Wait, the second one, did I? Oh, sorry, the second one I made a mistake while copying it. This was supposed to be 1. Otherwise, I couldn't do anything with that. This would be integral from 1 to 4 gx dx. Now, looking at this one, this goes from 1 to 2, 2 to 3. The first one will give me one integral of this form. Now, I'm subtracting from that 1 to 4 of f of x dx. I can write the rest here. 1 to 4 is bigger interval than this one. How about I can break this into two pieces, and I can write that as, this is the first one, minus, the second one I can write 1 to 3 plus 3 to 4 of f of x. This now cancels with this one. The remaining one would be negative or since I wanted to write it in one term, one integral, I can write it that way. I can take the negative sign inside. Any questions, any comments? Would you like to do another iClicker question? Yes. Do another iClicker question. And you will get 90 seconds to complete that. Go ahead, please. Okay, I will first flip the bounds, and I'll get it to 1, 2, but that will introduce a negative sign here. I know that if I go from A to B, I can rewrite it as A to C, and then from C to B. Yeah? There's a negative sign. The integral of ft from 1 to 3, this given, it is 3, plus integral of ft from 3 to 2, it is 10. That is 13, but we had a negative sign multiplied to that. That makes our number negative 13. Have a great day. Have a good weekend. Come back next week. We have lots of work to do on definite integrals. Make sure that you submit your response for the iClicker question. the continuation of the